So the main aim of this presentation is to compare and contrast the main features and advantages of each method so that we can get a better idea of what kind of methodology to employ on any particular project. Of course, each methodology has its advantages and disadvantages, and I'll be going over those in some detail. Neither method can make the claim of being the objectively superior design methodology because they are both suited to different types of projects. So before comparing the attributes and qualities of each method, I'd first like to give you a basic rundown on the fundamental differences in perspective between the two development methodologies. They diverge in the way they model the business or organization. So the structured approach focuses primarily on the processes of the business. It looks at the logic behind these processes and the data to be manipulated by these processes. So essentially, it looks at the processes, the logic, and the data. Whereas the object-oriented approach focuses more on the objects of the business and the use cases that involve these objects. We will attempt to define these concepts of process and object just so we get a better understanding of the essential motives behind each methodology. So with objects, what is an object? Just as the real world consists of various clearly defined objects that interact with each other, object-oriented methodology holds that the object is the basic unit by which we organize knowledge and model the business processes. So objects have three aspects to them. What it knows, which is its identity and attributes. What it does, its methods, otherwise known as functions. Who it knows is relationships to other objects. Examples of an object in a business context might include an invoice, an employee, a phone call, or a client. Objects and the relationships between objects and business processes are represented by a series of diagrams and models collectively known as the Unified Modeling Language, which is a set of standards agreed upon by the development community. Now let's look at what is a process. So a process in the context of structured design refers to a clearly identifiable and delimited transformational operation within the business that fulfills a specific function, basically by capturing, manipulating, storing, or distributing data somehow. So the analysts, once having identified all the key business processes, will then graphically represent the processes, the associated data flows, and the data storage areas in a diagram called a data flow diagram. So the structured approach to development first determines the requirements of a certain project. Then it structures these requirements by modeling the processes and logic of a proposed system. And there's a little diagram you can see here with an example of process modeling. Each process takes an input and produces an output. So we've looked at the distinction between an object and a process. That's the first key point of differentiation between the two methodologies. The next point of differentiation we will look at is how the system development lifecycle differs between the two approaches and the order in which parts of the cycle are done, depending on the chosen methodology. One thing to remember though before proceeding is that software engineering is a relatively new and extremely broad profession. There are no real hard and fast rules that must be adhered to. A system development lifecycle is really a guideline only, and depending on the project, steps may be skipped, reiterated over many times, or bypassed altogether. With that in mind though, authors and academics generally suggest that the traditional structured approach uses a formal incremental approach to the phases in the life cycle. Some people call it the waterfall model. So that one step in the process cannot begin until the previous step is completed. This is a top-down approach, so things are done in a logical order. The business problem or opportunity is examined first, followed by project feasibility and requirements. Then requirements modeling, logical and physical design, implementation and maintenance. The models are derived from initially analyzing the business or organization, then decomposing the business into process models. The data and logic are then evolved from these process models. So the system is developed as a whole, so to speak. It is seen as a singular project with process measured as a percentage of the whole project completed. And although there are exceptions, development generally only moves forward in the life cycle and never backwards. Now, in contrast, object-oriented methodologies take the view that as the system is defined as a collection of interacting objects, so too the project is viewed as a series of components that when combined will yield the entire system. So in this methodology, the system development lifecycle is an iterative and bottom-up process rather than a step-by-step process. Groups of components are divided into project activities based on the use cases of the project, and this allocated group will perform all steps of the life cycle, from management and planning right through to implementation and operation. The results of the iteration are then used as an input to the next iteration, and the cycle continues until all elements of the project are completed. One popular methodology used with object-oriented design is the unified process. So in this process, as you can see a model of it here, phases of the life cycle are divided into the inception, elaboration, construction, and transition phases. In each phase, all the steps of the traditional life cycle process are performed, to varying degrees though. The graph shows that the relative time and effort spent on each step of the life cycle changes depending on the phase of the project. For example, the construction phase shows a high level of time spent on the implementation step. So you can see then that the object-oriented approach is more of a bottom-up approach, because the entire life cycle must be done within one iteration. So individual components of the system must be fully designed and implemented before the system even has a completed project plan. Generally, project managers only plan 1 or 2 iterations ahead, rather than making highly detailed future plans, as in structured development, because I guess testing and iterations may require that components are radically changed, or can even show that the system design itself is flawed. And just continuing on with the differences in life cycle, as the various stages of the development life cycle are done at different times for both methodologies, so too the actual programming or implementation phase is done at different stages. So with structured design, the development phase is usually left to the programmers after the analysis and design phases have been completed in full. So all that's left for the programmers to do is implement the design according to rigid specifications. In contrast, the object-oriented approach allows for programmers to begin work during the actual design phase. As the iterative and bottom-up nature of this methodology means that development occurs while the system requirements are still being gathered, while they're still being determined, and the separate classes are being designed and implemented together. This means generally that system analysts on an object-oriented project need to be more technically capable, as they need to be able to specify classes, methods, and messages and implement these on the fly. Another difference between the two approaches is how they structure application logic and control. Let's have a look at the differences between that. Structured design employs a military type of model, whereby a controller module performs only the control functions, and worker components or modules carry out individual processes. Implementation into code is generally easier in structured design, as tasks can be clearly broken down into modules and tight control over the modules is easily achieved. In structured design, the components are tightly integrated into the design. In contrast, in object-oriented design, the system control is partitioned into the many objects that comprise the system. Objects can exist to carry out various control options. For example, you can have objects that manipulate data, objects that perform computations on data, or objects that monitor other objects for occurrences of key events. It's designed principally with reuse in mind, so designers don't have to reinvent the wheel, so to speak. If an object performs a certain data transformation, it could be reused within a completely new system given the appropriate data types. Now, moving from the design phase to the implementation phase involves moving logical and abstract designs, such as your diagrams, into real-world software architecture components, such as the user interface, application logic, and data stores. The implementation of physical system components from abstract models developed during the design analysis phase differs. It's different depending on the system design methodology used. So in the case of structured design, the analyst will usually develop a data dictionary, which is a repository of information about data used in the system, which is called metadata, data about data. This dictionary is derived from information in the data flow diagram, such as the data stores and the data flows. Data stores are designed using the entity relationship diagrams. The application logic is broken down into modules, which is obtained by breaking down processes in diagram data flows into structure charts, and further decomposing into logical modules. Finally, the user interface, the input-output forms, and the reports are all developed. So, as you can see, there's a clear mechanism by which processes, logic, and data are modeled and then implemented into the physical designs and physical implementation. So contrasting this, one of the weaknesses of the object-oriented style is that there is not really a concrete method of transitioning the abstract models into a complete functional real-world model. For example, when building a complex application, it may not be possible to model all of the possible use cases. It might be impossible to think of every single use case involving actors and scenarios. So application requirements could be missed during the analysis phase. Sequence diagrams, use cases, and class diagrams can all be used to extract application program specifications and data specifications. The process is just not as clear-cut as with structured design. Therefore, it's vitally important when selecting a style of methodology for developing a new project that if object-oriented design is chosen, the lead analyst has substantial experience in object-oriented design and development. So now that we've looked at the differences, some key differences between the two methodologies, let's now look at 3 key features of object-oriented design. We'll go over these in some detail just to give you an idea of the type of project that object-oriented design might be more suited to. The first feature we'll look at is scalability. Now we've got a UML use case diagram here. Now this shows a very basic example of how scalability can be used. The extend keyword in this diagram shows that a use case is a more specialized behavior of its more general process. So it's basically an extension of a use case, which is what scalability refers to. In this example, assign window seat and assign aisle seat are essentially the same activity as assign seat, but are more specialized versions. This is a key element of scalability. If we wanted to extend the program further using object-oriented design, it's a lot easier than using structured design. A scalable program is one where the developer can increase the size, functionality, or features of the program with a linear increase in difficulty according to the complexity of the additions. With structured design, in certain situations, scalability doesn't exist. Trying to extend the program doesn't correspond to a linear increase in difficulty. So scalability is essential for projects where it's thought that upgrades or additional features will need to be built into the software at a later date. Okay. Another key feature of object-oriented design is that its objects are reusable in other projects or software. Because of the encapsulation quality, objects are self-contained pieces of logic that can easily be reused in other systems simply by accessing the object's interface, even if not much is known about the object's implementation. So using the principle of polymorphism, we can also add additional features to an object that the original designer did not intend for. For example, polymorphism allows a method to have a different functionality depending on the instance of the class it is operating on. So it makes it easier to reuse a given component or method in a wide range of new contexts. As you can see here with this very basic sample interface of a phone call. So in order for another developer to use the methods and data contained within, all they'd have to do is call the publicly available methods from another object, so long as the required parameters are correct. Some common examples of object-oriented based reuse include JavaBeans, ActiveX, and DirectX by Microsoft. Object-oriented design is also very compatible with next-generation paradigms such as service-oriented architecture, where a system is viewed as a collection of services, and cloud computing, where data objects can be accessed in the cloud. The final step in the traditional systems development lifecycle is maintenance. Now this is very important because studies have shown that historically most development effort and cost goes towards the maintenance phase. Object-oriented design was developed in part to try and alleviate the time-consuming and difficult nature of software maintenance. So whilst it's not guaranteed that an object-oriented project will be easier to maintain, it's generally accepted within the software community that such projects are less vulnerable to drastic changes in requirements. Due to the encapsulated and self-contained nature of objects, it can be easier to identify bugs and errors, as objects usually have localized variables which are easier to trace. Having said that though, academic research tends to suggest it is not an indisputable fact that object-oriented style leads to easier maintenance. For example, Deligiannis et al. In their 2004 paper state that project outcomes are very sensitive to bad or good design practices. So in other words, if object-oriented principles are violated or not used correctly, there's a greater possibility of maintenance changes becoming increasingly difficult and leading to entropy. So having gone over and compared some key elements of both design methodologies and examined in more detail some key features of object-oriented style, let's now have a look at what kinds of projects are more suited to each particular methodology. Whilst I've preached the virtues of the object-oriented method, it's not necessarily the best choice for all project types. Indeed, there are some projects that are more suited to the traditional structural procedure-based approach. In particular, projects where constraints are imposed, such as memory and time constraints. In the case of real-time systems, such as an alarm system, microwave oven system, or aircraft control system, one might not want the memory overhead associated with objects, although this can be negligible depending on the language used. Object-oriented methodology, though, is very suitable for a wide variety of project types, including most business applications, due to the natural transition of modeling real-world business objects and data to the object-oriented techniques. So, to conclude this presentation, we will look at a summary of the general steps in the life cycle to implement the two different types of projects and the comparative timescale between the two. Now, when you're employing object reuse, object-oriented design is faster because it involves less development time in designing and implementing. The necessary objects can just be incorporated into the new project via their interface. However, due to the complexity in designing an object-oriented solution from scratch and modeling an entire organization as a series of objects, can be slower building a new project and generally requires more experienced analysts. Structured design is a more tried and tested, proven method of developing software. And if risk is an important factor in a new project, it might be worth sticking to the structured methodology as it allows for a more careful, detailed, and rigorous project plan. As far as timeframes for development go, if you have a team that is experienced in structured development, the life cycle may be faster when employing the structured method as it's a more clearly defined and well-known process. However, when the project has been implemented and the maintenance phase is underway, object-oriented methods may have an advantage due to the encapsulated and loosely coupled nature of the software design.